In 1935, Albert Einstein called it spooky action at a distance. He refused to believe it. He died refusing to believe it. But a new experiment 98 years in the making has just proven him wrong. This is the story of the greatest debate in the history of science. A clash of titans. Albert Einstein, the father of relativity, versus Niels Bohr, the architect of the quantum world. Einstein believed in a universe of elegant, predictable laws, where nothing, absolutely nothing, could travel faster than the speed of light. It was the bedrock of his reality. But the new theory of quantum mechanics presented a terrifying possibility. A world of uncertainty, of probability, and of a strange connection between particles that seemed to defy space and time itself. This was quantum entanglement. Two particles linked in a way that if you measure one, you instantly know the state of the other. It doesn't matter if they're a millimeter apart or on opposite sides of the universe. The connection is instantaneous. To Einstein, this was a phantom, a spooky action at a distance. It violated his cosmic speed limit. He was convinced quantum mechanics was incomplete, that there must be some hidden information, some local hidden variables, that we just couldn't see. For decades, it was a philosophical argument, a stalemate, until 1964, when a physicist named John Bell devised a test, a mathematical theorem that could finally put the debate to the ultimate experiment. Bell's theorem was ingenious. It proved that if Einstein's hidden variables were real, the correlations between entangled particles would have a limit. But if quantum mechanics was right, that limit would be broken. And in the 1970s and 80s, a series of groundbreaking experiments led by Alain Aspect, John Clauser, and Anton Zeilinger did just that. They broke the limit. They violated Bell's inequality. For this, they would win the 2022 Nobel Prize in Physics. The results were clear. The universe is spooky. There are no hidden variables. The connection is real. But the question remained, how fast is it? Experiments have shown that this spooky action happens at least 10,000 times faster than the speed of light. But for all practical purposes, it is instantaneous. And just this year, in January 2026, the final nail was hammered into the coffin of Einstein's objection. Physicists at the University of Science and Technology of China performed a modern version of a thought experiment Einstein himself proposed back in 1927 to disprove quantum mechanics. Using a single cooled rubidium atom as a beam splitter, they proved, with stunning precision, that Bohr was right all along. The very act of measuring one property of a particle introduces an uncertainty that makes it impossible to know a paired property. The universe, at its most fundamental level, is a game of chance. Einstein was wrong, but in being wrong, he pointed us toward the most profound and powerful discovery in modern physics. So what does this mean for us? If we can't use it to send information, what's the point? The point is everything. This isn't about faster-than-light travel. It's about a new kind of communication, a new kind of computation. It's the dawn of the quantum internet. In December 2025, scientists at Stanford announced a breakthrough, a room-temperature quantum device. No more supercooling. No more massive, impractical machines. This is the beginning of quantum technology that can fit in your phone. At the same time, researchers at the University of Chicago extended the range of quantum networks from a few kilometers to a potential 2,000 kilometers. A global, unhackable internet, secured by the very laws of physics, is no longer science fiction. It's on the horizon. This technology will revolutionize everything. Medicine, materials science, artificial intelligence, finance. It will allow us to solve problems we once thought were impossible. Albert Einstein looked at the universe and saw a beautiful clockwork machine. He couldn't accept a reality built on chance and spooky connections. But the universe is stranger, more wonderful, and more deeply interconnected than he ever imagined. We don't live in a clockwork universe. We live in a quantum one. There is something faster than light. It's the invisible thread that ties the cosmos together. And we are just beginning to learn how to pull on it. The quantum age has begun.